Hey there. I'm going to try to go quickly through this Unit 6 free response question, Part A, number 2, just to give you guys a verbal answer key, basically. So first part is A. We're going to evaluate from 0 to 7 f prime of x dx. We're given the graph of f prime. Really important to notice that. So this literally says find the area under the curve from 0 to 7 of f prime of x dx. So to solve that, I'm just going to add up those areas that were given from 0 to 7, knowing that below the x-axis is negative. So I have 2 plus -7 plus 3 plus 1. Of course, that would be a good final answer. I'm going to add them together, get -5 plus 4 is -1. That's it for part A. For part B, this is the long part. Given f of 4 is equal to 10, express f of x involving integral, and then find the absolute max and min on 0 to 7. So I may paraphrase that a little bit. Okay, we're trying to find the absolute max and min of f. I'm given a graph of f prime. So they give me this info. Just probably going to have to use that at some point. And we're going to be using the fundamental theorem of calculus to help us solve this here. I just wrote it on the side. So it's the fact that if you take the integral of a derivative, you go back to the original. And that first fundamental theorem of calculus says you evaluate f of x minus f of a. So we can rewrite this function here. We can use, we want to use the number that we know for x. We know f of 4 is 10. So I'm going to write the integral from 4 to x of f of t dt. I just can't use x again. I need a different letter. Okay, equals f of x, and that should be f prime of t. Sorry, f prime of t dt. Then we plug in f of x minus f of 4. So I can isolate f of x there, get f of x equals the integral from 4 to x of f prime of t dt, and then I would be adding f of 4 to both sides, but f of 4 we know from over here is 10, so plus 10. So I'm going to use that later, because if I want to find the absolute max or min on f, I need to be able to evaluate what are the values of f of x. So now I need to figure out what values go in my candidates chart for finding the absolute max and min. So candidate chart. So we've got candidates chart here. I know my endpoints are 0 and 7, so I just need to figure out if there are any critical numbers between there that I need to test. So critical numbers come from setting the derivative equal to 0. So f prime of x equals 0. And you might think, oh, I have to take the derivative of this, but wait a second, that's the graph we're given, is f prime of x. And so if I want to know when that derivative is 0, I just look for the x-intercepts here. So this is going to happen at x equals 1, 4, 6, and 7. Okay, so you could plug those 4 critical numbers in there. 7's already our endpoint, so we've got that taken care of. 6, you'll notice on the graph, actually won't be a max or min because the derivative doesn't change signs. If you look up at the graph, it stays positive, so we can't. The 6 won't matter either because can't be max or min since f prime doesn't change signs. So I've got 1 and 4 are the critical numbers I need to test. So in my sign chart here, not sign chart, in my candidates test, I've got an endpoint, I've got a critical number, another critical number, and I have another endpoint. As soon as you see absolute max and min, you know you need a candidates chart. All right, so I have to evaluate these 4. So we're going to go f of, well, 4 I already know. F of 4 we were given is 10. So the rest I have to evaluate. So we're going to go f of 0, and I'm using that function f of x right here. F of 0 is the integral from 4 to 0 of f prime of t dt. plus 10. Well, I can use the graph up above to help me answer that question. I know the integral from 4 to 0 means I'm going backwards, so it's going to be the opposite of, and then I just have these two areas here, the 7 and then the 2. So the 7 is negative because it's below, and then the plus 2, and I have plus 10. So that one would be negative 5, but opposite, so 5 plus 10 is 15. So I have f of 0 is 15. So I'm going to skip through and get these next two answers up there quickly. Okay, so you do those next two the same way we just did f of 0, and you find out that f of 1 is 17, and f of 10 is, or sorry, f of 7 is 14. And from here we can state our answer. So we can say that we have an absolute maximum of f is, and then you could say the 0.117, and then absolute minimum of f, sorry I forgot f on there, is, and that's going to be 10, so 4 comma 10, and then we should say over the interval 0 is less than x is less than 7. Alright, C and D are much quicker. Part C here says evaluate integral of g of x dx, and we were given that g of x is 5 minus x squared. So this is literally just plugging in. So 5 minus x squared dx, do you know your integral rules? That's going to be 5x minus x to the third over 3 plus c. This is worth 1 point, you will not get the point if you don't have plus c. And D, evaluate this integral from 1 to 2 of x times f prime of g of x dx. Whoa. Anytime I see something like this, my first thought is use substitution. You've got like this function that's called a derivative, and there's something on the outside of it. I'm thinking use substitution right away. So let's see what that would look like. I first might sub in, so I might call this 1 to 2 of x f prime of 5 minus x squared, because I know that's what g of x is, dx. And so then I'm thinking, oh, okay, here's my u substitution. I'm going to let u equal 5 minus x squared, so du would be negative 2x dx. And I want x dx, so I'll go negative 1/2 du equals x dx. And so now I can do the u substitution. I'm going to have the integral from, I need to change my bounds. So when x equals 1, that's going to give me u equals 5 minus 1 squared, so 4. 5 minus 1. And then when x equals the top bound 2, I get u equals 5 minus 2 squared, so 5 minus 4 is 1. So I'm going to go integral from u to 1. X dx is my du, but it's times negative 1/2, so I'll put that in front. And then I have f prime of 5 minus x squared, that's f prime of u du. So that is my function that I have a graph of. So once again, I can do this integral using the graph. So I'm going to have negative 1/2 times, and the value of that integral backwards from 4 to 1 would be opposite of negative 7. And so we get positive 7 times negative, so we get back to negative 7/2. And that's your answer. All right, hope that helped.